A dwarf planet and the largest body in the Kuiper belt, Pluto was once considered the ninth planet of the solar system. However, it later lost the status. The discovery of Pluto dates back to 1930, when we observed a few faint gray pixels in our telescopes. Over the years, we still knew very little about this planet until the New Horizons spacecraft sent back the most detailed images of its surface and its moons. But how did we reach the farthest planet in the solar system, and what did we see there? The New Horizons spacecraft has now reached a distance of 12,500 kilometers from the surface of Pluto to send the highest quality images recorded by humanity of this distant stranger. The $723 million mission of New Horizons began in January 2006 to gather information from the last planet of the solar system. This spacecraft uses 7 different instruments and, through a highly coordinated operation, sends data back to Earth from billions of kilometers away. In the early decades of the 20th century, observations of irregularities in Neptune's orbit led many astronomers to suspect that a ninth planet might exist in the outer layers of the solar system, while Neptune itself was discovered through the irregularities it caused in Uranus's orbit. Young astronomer Clyde W. Tombaugh discovered this planet by noting a positional change observed over a week in images he captured. 11-year-old Venetia Burney suggested naming the planet Pluto after hearing about the discovery. In Roman mythology, Pluto is the god of the underworld. Pluto and its largest moon, Charon, form a binary system, rotating around a center of mass located 1/8 of the distance between them due to Pluto's 8-fold greater mass compared to Charon. For the first time, the color of Pluto's surface is revealed from images taken by the Hubble Space Telescope. This is the most we have been able to observe from the surface of Pluto from this distance. Astronomers consider 4 regions for the solar system. The inner region includes the planets Mercury, Venus, Earth, and Mars, while the outer solar system consists of Jupiter, Saturn, Uranus, and Neptune. However, Pluto, along with the Kuiper belt, is located in the third region, known as the trans-Neptunian region. This frozen world is so distant that it takes more than 4 hours and 20 minutes for radio waves traveling at the speed of light to reach Earth. In the fourth area of the solar system, distant clouds are located. This unreachable region is over a light year away from the Sun. New Horizons is the first spacecraft to fly past Pluto. Initially, it was thought that Pluto was a planet the size of Earth, but it later became clear that this icy world is only 2/3 the diameter of the Moon. New Horizons will not stop at Pluto but will continue toward the outer layer of the solar system or the Kuiper belt, where an unknown object named PT-1, potential target 1, is believed to exist. New Horizons is set to reach this target in January 2019. This spacecraft consists of 7 separate components, 3 cameras, 2 plasma devices, a dust sensor, and a radio transmission and reception system, each consuming between 2 to 10 watts of power, less than a small light bulb. New Horizons goals. In 2006, after its launch, this was the first image sent back to Earth from the LORRI Long-Range Reconnaissance Camera of New Horizons, marking the beginning of a journey of 4.7 billion kilometers that has lasted over 9 years to date. Power source. A system the size of a small piano is responsible for powering New Horizons, which is fed by a radioisotope thermoelectric generator, RTG. The 200-watt atomic battery generates the power needed by New Horizons using thermal energy from the decay of 11 kilograms of plutonium. This technology had been used in the Voyager spacecraft and Apollo moon missions years ago. In the image on the right, you can see the isotope plutonium-238, which is melted due to atomic decay. Pluto's moons. Only 2 years have passed since the discovery of all of Pluto's moons. On July 2, 2013, the International Astronomical Union officially confirmed the existence of 2 moons, Kerberos and Styx, for Pluto. New Horizons in human knowledge. Images captured by the Long-Range Reconnaissance Imager, LORRI, are sharpened using a method called deconvolution, enhancing the details of these images. Sometimes this process can produce inaccurate details, so images from a closer distance are needed to confirm the accuracy. In this unreal image, the brightness and size of Pluto's 5 moons Nix, Hydra, Kerberos, and Styx are compared with Charon. This imaginative image predicts how Nix, one of Pluto's moons, will change shape while passing between the gravitational pulls of Pluto and Charon. This image is created from a combination of 48 10-second images taken by the LORRI camera on June 26, 2015, from a distance of 21.5 million kilometers from Pluto. The data shows Pluto's diameter as 2,370 kilometers, with Charon, Pluto's largest moon, visible in the left image. In this graphic, the size of Pluto and Charon is compared to Earth. Information received from New Horizons indicates that Pluto's size is 18.5% that of Earth, while its moon Charon is 9.5% the size of Earth. After more than 9 years, the spacecraft is sending significant information about the farthest known planet in the solar system back to Earth. In the image above, Ralph, using the LASA spectrometer, has detected the distribution of methane gas on Pluto. New Horizons sends stunningly detailed images of Pluto's moon Charon back to Earth. On July 15, 2015, at a conference at Johns Hopkins University, NASA announced that it had obtained the clearest photos of Pluto's surface. These images reveal young ice mountains reaching heights of up to 3,500 meters, as well as 3.5-kilometer high ice mountains and 10-kilometer deep valleys, indicating geological activity in this frozen world in the not-so-distant past. Finally, in the latest images from the New Horizons spacecraft, a strange mountain is observed on Pluto's large moon Charon, surrounded by a trench, making Charon more intriguing for scientists. These mountains are one of the phenomena that have amazed geologists, with the image taken from a distance of 79,000 kilometers. This is the most recent image released by NASA of Pluto and Charon. We are still awaiting higher detail images of Pluto's surface, perhaps from PT-1 in the future. How was Pluto discovered? Percival Lowell, an American astronomer, first suggested the existence of Pluto in 1905 while observing strange anomalies in the orbits of Uranus and Neptune. Lowell thought there must be another body whose gravity was affecting the ice giants and causing the discrepancies in their orbits. In 1915, he predicted the location of the mysterious planet. However, he passed away 15 years before it was discovered. Ultimately, Clyde Tombaugh discovered Pluto in 1930 at the Lowell Observatory in Arizona, based on Lowell's predictions and those of other astronomers. Pluto was named after the Roman god of the underworld based on a suggestion from an 11-year-old girl from England named Venetia Burney. When the news of the discovery of the 9th planet was announced, Venetia suggested to her grandfather that the planet be named after the god. Her grandfather then communicated this suggestion to the Lowell Observatory. Additionally, Pluto's name also pays tribute to Percival Lowell as it contains the first 2 letters of his name. Pluto's surface is covered in a thick layer of frozen methane. However, scientists from New Horizons have observed significant differences in how light reflects off this icy surface across the dwarf planet. They found features similar to the ice blades on Earth or features formed by erosion in Pluto's mountainous regions. These surface features on Pluto are much larger, with an estimated height of 500 meters, while their Earth counterparts are only a few meters tall. Another distinct feature on Pluto's surface is a large heart-shaped region informally known as the Tombaugh Regio. The left side of this region, the area resembling an ice cream cone, is covered in frozen carbon monoxide. Scientists have identified other changes in the chemical composition of the materials in Pluto's heart. At the center left of the Tombaugh region lies a very smooth area that the New Horizons team has informally named Sputnik Planum in honor of Sputnik, the first artificial satellite to orbit Earth. This region of Pluto's surface is devoid of impact craters, a characteristic that indicates Sputnik Planum is a very young geological area, likely less than 100 million years old. It is possible that this area is still in the process of forming and changing due to geological processes. Pluto's icy plains show dark streaks measuring several kilometers in length, aligned in the same direction. These lines are believed to have been formed by the strong winds that blow across the surface of the dwarf planet. The Hubble Space Telescope has also provided evidence that Pluto's crust may contain complex organic molecules. The surface of Pluto is one of the coldest points in the solar system. Temperatures there can drop to around -226 to -240 degrees Celsius. Comparing images of Pluto taken at different times has shown that this dwarf planet has apparently become redder over time, likely due to seasonal changes. Pluto may currently have a subsurface ocean or may have had one in the past. However, there is still no consensus on this matter. If an ocean had formed beneath Pluto's surface, it could have had a significant impact on the history of this dwarf planet. For example, scientists believe that the Sputnik Planitia region became so heavy over time due to the increasing volume of ice that it caused Pluto to tilt, bringing its axial tilt to its current angle, about 120 degrees. Researchers suggest that a subsurface ocean is the best explanation for this phenomenon. If Pluto has a liquid ocean and enough energy, it could potentially be a refuge for life. What is Pluto made of? Some of the elements that make up Pluto, according to NASA, are as follows: atmospheric composition, methane and nitrogen. Observations from New Horizons indicate that Pluto's atmosphere extends up to 16 kilometers above the surface of this dwarf planet. Magnetic field. Scientists still do not know whether Pluto has a magnetic field. However, the small size and slow rotation of this dwarf planet suggests that such a field is weak or does not exist at all. Chemical composition. Pluto is likely composed of a mixture of 70% rock and 30% water ice. Internal structure. The dwarf planet likely has a rocky core surrounded by a mantle of water ice, with unusual frozen elements like methane, carbon monoxide, and nitrogen covering its surface. Orbital characteristics of Pluto. Pluto's highly elliptical orbit can take it more than 49 times the distance from the Earth to the Sun. Because the orbit of this dwarf planet is highly eccentric, its distance from the Sun can vary significantly. In fact, for 20 years of its 248-year orbital period, Pluto was closer to the Sun than Neptune, providing a rare opportunity for astronomers to study this small, cold, distant world. As a result of such an orbit, after being considered the eighth planet from the Sun for 20 years, Pluto passed Neptune's orbit in 1999 and became the farthest planet from the Sun until it was ultimately reclassified as a dwarf planet in 2006. When Pluto gets closer to the Sun, its surface ice melts and temporarily forms a thin atmosphere mostly composed of nitrogen and some methane. Pluto's weak gravity, which is just over 1/20th that of Earth, allows this atmosphere to extend to much greater heights compared to Earth's atmosphere. As the dwarf planet moves farther from the Sun, much of its atmosphere appears to freeze and disappear. However, when Pluto has an atmosphere, it likely experiences strong winds. This atmosphere also exhibits variations in brightness, which can be attributed to gravitational waves or airflow over the mountains. Although Pluto's atmosphere is too thin to allow liquids to flow today, liquid elements may have been active on the ancient surface of the dwarf planet in the past. New Horizons captured an image of a frozen lake in the Tombo Regio area, which appeared to have ancient channels nearby. At one point in its history, Pluto could have had an atmosphere nearly 40 times thicker than that of Mars. In 2016, scientists announced that they might have detected clouds in Pluto's atmosphere using data from New Horizons. Researchers observed 7 bright features near the boundary between light and dark, which is typically where clouds form. These potential clouds were all low in altitude and approximately the same size, suggesting they are distinct features. If these clouds do exist, their composition is likely to include acetylene, ethane, and hydrogen cyanide. Interesting facts about Pluto's orbit. Pluto's rotation is retrograde compared to other worlds in the solar system, meaning the dwarf planet rotates backward from east to west. Average distance from the Sun, 5,906,380,000 kilometers or 39.4 astronomical units. Aphelion, farthest distance from the Sun, 7,304,326,000 kilometers or 48 astronomical units. Pluto's orbital path around the Sun is not in the same plane as the 8 planets of the solar system, rather, it is tilted at an angle of 17 degrees to it. Does Pluto have moons? Pluto has 5 moons: Charon, Styx, Nix, Kerberos, and Hydra. Among these, Charon is the closest moon to Pluto, while Hydra is the farthest. In 1978, astronomers discovered that Pluto has a very large moon, nearly half the size of the dwarf planet itself. This moon was named Charon, after the mythological figure who guided souls to the underworld. Because Charon and Pluto are very similar in size, their orbit is quite different from most planets and their moons. Pluto and Charon effectively orbit around a point in space that is located between them, much like binary star systems. For this reason, scientists refer to Pluto and Charon as a double dwarf planet, a binary planet, or a binary system.